Alrighty, so Mr. Ackerman is most likely going to be out tomorrow, so his students are most likely going to be watching this video as their lesson tomorrow. Say hi to Mr. Ackerman, students. And Vedika, we can't forget Vedika, because she won't be the only one that's watching it. Okay. All right, this is going to go on page 50. Oh, goodness gracious. Yikes. Let me fix that. Okay. Going on page 54 when we are done. No, AB, just third period. BC's way ahead. Okay, I shouldn't have, yeah, you didn't even say hi to God. Goodness. Yeah, so now focus. Maybe I shouldn't have told you all that. All right, so we're going to look, we did the first derivative test. Now we're going to look at concavity and the second derivative, all right? So concavity, if we have something that is concave up or concave down, and when I said concavity yesterday, y'all acted like you'd never heard it before. Is that a true statement? Okay, just making sure, because I'm a little discombobulated on this stuff right now, because in AP Pre-Cal, we've talked about it a lot. And I don't think we talked about it at all last year because it just wasn't in the curriculum. So, and then because of all that, I wasn't sure if we had talked about it yet. Just stop it. I shouldn't have given you candy either. Okay. So, concavity. Listen, we want to know what it looks like visually, but we also need to know what it looks like algebraically. So, the graph of F is concave upward. So, concave upward basically looks like that. It's concave up, like a cup, like it can hold water, right? On the interval of I, if F prime, so look, F is concave up, if F prime is increasing. Okay. And then the graph of F is concave downward, which would mean like this, like all my water is going to spill out, on an interval I if F prime is decreasing. Now, one thing, I don't want you to think about it really, I mean, that's kind of how we draw concavity when we're just like doing a quick little sketch of whatever, but it doesn't literally have to be able to hold water. Okay, so if we think about a phone, okay, hang on. Okay, so because we struggle with this one anyway, let's just sketch really quick f of x equals e to the x, okay? And so if I sketch that, it's exponential. Do we know what it looks like? Okay, so it goes like this, right? Whoop. Yes? Okay, so that's f of x. What is the derivative of e to the x? E to the x. So guess what? On this particular one, that's what f prime looks like also, okay? So f prime is increasing. Would you agree with that? Which makes that one concave up. But because like it approaches 0 down here, it doesn't actually like hook back up on the left-hand side, but it's still concave up, but it's because the derivative is increasing. Another way to look at that, so let's say that we didn't know that the derivative was e to the x. The derivative is the slope of the tangent line, right? So if I put little tangent lines here, then I can see that my slope is actually increasing, and you can look at it that way as well. Okay, we good with that? Okay, perfect. Then, so the way we're going to test for concavity, let f be the function whose second derivative exists on an open interval, okay? So if f double prime is greater than 0, what's another way to say that? Positive. For all x in the interval, then the graph of f is concave up in I. Okay, concave up, positive. See how it makes a smiley face? Oh, look at that. F double prime is less than 0. What's another way to say that? Negative. Okay. If f double prime is negative, then f is concave down. And then that's concave down, and see how the negative makes you sad. Okay. Hey, whatever works for you to remember it. That's all I care about. Okay. Then we have an inflection point. Do you know what an inflection point is? Yes, can you tell me what it is? That's okay. Tell me a graph that you know that has an inflection point. I heard it. Who said it? Cubic. Very good. Okay. So one of the functions that you are already familiar with is the cubic, right? Okay. And the cubic has an inflection point right there. It's the wiggle. Remember when we talked about wiggles? It's where we wiggle. Okay. That's our point of inflection. All right. Inflection point of inflection, same thing. Okay. So it's where the wiggle happens. But really, what's happening, because we talked about it as a wiggle, or where it, we're not really this is increasing the whole time, right? It's not changing from increasing to decreasing. It just kind of wiggles a little bit, right? And so it has an inflection point if f double prime of c equals 0, or if f double prime of c does not exist. Okay, now let's just pause for a second. When we took the first derivative, we set it equal to 0, right? And we found these zeros, and then that's where what would happen? Extrema. Okay, so I'd either have a relative max or a relative min, right? The zeros of the second derivative and the does not exist, that's what gives us the point of inflection, okay? So we get extrema from the first derivative, we get points of inflection from the second derivative, basically by kind of doing the same process, all right? So this has to be true, and f double prime changes signs from positive to negative, or negative to positive at x equals c. So that's f double prime. So if f double prime changes from positive to negative, that's where the sign chart comes in. That's how we figured that out, right? Or if f prime changes from increasing to decreasing, or decreasing to increasing. Okay. Everybody okay with that? Now, we're going to take a little bit of room over here, because we don't need all that room for that. And remember yesterday, I think it was yesterday or day before, I don't remember what day it was, but sometime this week, I told you there was a fun chart, right? Okay, so really I'm calling it the fun chart 2.0 because we have a fun chart in pre-cal now, and this used to be called the fun box, and I just don't like the way that sounds. So we're going to call it the fun chart. Yeah, I know, exactly. We'll call it fun. I made an executive decision. We're changing the name. I don't like it. So fun chart. It's the only fun chart you know, but see, maybe I shouldn't even have said that. Sorry. At least I got y'all to laugh. At least I know you're paying attention. That's all I needed to know, really. Okay, fun chart. So this is our fun chart F, okay? And then we have concave up, concave down. That's what makes it look like the fun, right? So you know it has to go up, down to spell fun. And then everything else is up, down, up, down. So then we go increasing, decreasing. Then we have F double prime. And you start over with increasing, decreasing, then positive, negative. And then we have F double prime, positive, negative. Oh, crap. Good Lord, sorry. I was still distracted by the fact I shouldn't have said what I said to you. So, like, what did you learn today in calculus? Right. Yeah, you're right. I'm sorry. And I don't know if I said the right thing and wrote the wrong thing. So let me restate everything. I know I'm recording. It's okay. If I haven't lost my job by now, it's not going to make me lose my job. It's fine. Hey, Edmund. Hey, jury. I don't know. All right, so F, and then this is F prime. I'm not sure what came out of my mouth, but F prime, increasing, decreasing, positive, negative, then F double prime, positive, negative. Okay? This little fun chart right here, this gives you, okay, hang on, because now I moved that stupid ball. Well, all right. The fun chart. This fun chart tells you everything you need to know on all those little things that we just set up, all these little rules that seem overwhelming sometimes that you have to remember. This gives you everything, okay? Because the thing that we need to know about concavity, which I thought was going to be written in here and it's not, definition of concavity. Okay, so concavity, let's write this up here. Concavity, okay? Oh, actually not with, we want to do it point of inflection. It would make more sense to write it here. Well, let's do it here. Let's do it here. I'm sorry, I'm still kind of distracted. An inflection point is where it changes concavity. So if we look at this cubic function here, starting from here to the point of inflection, it's concave down. And then there's a point of inflection, then it's concave up. And when we look at our slopes, if this is my function, and then I'm looking at the slopes of the tangent lines that are so hard to draw in the right place on this board. So you get to pretend like they're touching if they're not. So just pretend like those are touching. So we have our slopes here, okay? We have a positive slope, right? That is then getting closer and closer to 0. Therefore, the slope is decreasing, so it's concave down. Then we go to 0, and it becomes a more positive slope. So my slope, or my f prime, is increasing. So when f prime is increasing, it's concave up. When f prime is decreasing, it's concave down. This right here, where it changes concavity, this is your point of inflection. So it happens when, just like it says right here, f prime changes from increasing to decreasing, or f double prime changes from positive to negative, or vice versa. Okay? So if you draw the little fun chart, you can literally see where the point of inflection goes, right? And you can literally see right here, when f changes from increasing to decreasing, or decreasing, that's where you're going to have your relative max and min. So writing out this quick little everything, you don't have to do this in pink, but what I have in green, you just jotting that down at the top of your paper, this gives you everything you need. Okay? We good? Okay. Any questions at this point? All right, so then let's look at the graph of f is shown below. Now, so here's what's important again. When you have a graph, this is the graph of f. And if they give you the graph of f, chances are pretty good you're not going to get any questions about f. You're going to get questions about f prime and f double prime. All right? So, it says state the signs of f prime and f double prime on the interval from 0 to 3. So that's where the graph is, right? So let's see, f prime and f double prime is what we're looking for. So tell me something about f. What can you tell me? Just f itself, not f prime or f double prime. Okay, the function is positive. Is it increasing or decreasing? Decreasing. Is it concave up or concave down? Concave up. Okay, so if it is concave up and it is decreasing, is f prime positive or negative? And do we figure that out from concavity or increasing, decreasing? If I want f prime, and I'm talking about positive and negative, I'm looking at f increasing, decreasing, right? So I don't really care about the concavity to answer that first part. You with me? So I can see that f is decreasing, therefore f prime is negative. F prime is less than 0 or negative, you can write that. And then our reason, because we can't see f prime, we don't have an equation, we don't have a graph, it's because f is decreasing. Bless you. We good on that? All right, so then what do you think about f double prime? Positive or negative? If I'm looking at f double prime, and I'm looking at, is it positive or negative, f is what I'm going by, and so I need to look at the concavity. Is that concave up or down? Up. If it's concave up, f double prime is positive. So it's greater than 0 because f is concave up. We good? You see how to use that chart? It's going to come in real handy. All right. What questions you got? All right. For the following function, find the intervals on which f is increasing or decreasing. Do we already know how to do that? Yes. the x-coordinates of the local max and mins. Do we already know how to do that? And then the intervals of concavity and inflection points. We haven't done that yet, but you think we can figure it out? I think we can. All right, so let's look at this. So the A and B, that's what we've been doing, right? We've already been doing that. So let's find f prime of x. I'm going to give you a second. You find f prime of x correctly, accurately, with enthusiasm. What rule do we need to make sure that we use? Oh, man. Product rule, very good. Derivative of the first times the second plus the first times the derivative of the second. Do we all agree with that? Okay. So we're going to want to set that equal to 0. When we set it equal to 0, 3 times e to the x plus 3x e to the x. The first thing I want you asking yourself is, should I factor or can I factor? The answer is yes. So we're not moving anything over just yet, right? So I get 0 equals, what can I factor out? E to the x. 3e to the x, absolutely. 3e to the x. That leaves me with 1 plus what? X. Okay. So, and then I'm going to set both of these equal to 0, right? So 3e to the x equals 0, and 1 plus x equals 0. When does 3 times e to the x equal 0? Never, because we know what it looks like, right? E to the x looks like this. 3e to the x, what kind of transformation is that? It's just a vertical stretch, right? So if a vertical stretch isn't going to change that, I can't make that equal to 0, so that's irrelevant. And then here I get x equals -1. Yes. This transformation here, that's just a vertical stretch, right? So if you know what e to the x looks like, this just gets stretched, but it's still not going to put it below 0. There's still nothing I can substitute in for x to make this 0. Like, that's impossible. Okay? And then I just solved that for -1. So now that we've done that, what do we do with this information? Put it in a sign chart. Okay? So I'm going to put it in a sign chart, and all that I have on there is -1. And this is f prime that we're putting on the sign chart, right? Is there any, so not only is there no number I can substitute in for x that gives me 0, is there anything I can substitute in for x that's going to give me a negative number? Again, if you know what a graph looks like, you got any negative y's there? Nope. So this part right here is just always going to be positive, so it doesn't really matter what happens there, right? If I substitute in something less than -1, that's going to make this negative. And if I substitute something in greater than -1, it makes it positive. So that means for f, this is decreasing and increasing, just like we did before. Okay, so let's answer the A part here. So A says, find the intervals for which f is increasing or decreasing. So I've already told myself by what I drew on my number line, right? So f is increasing on what interval? -1 to infinity, -1 to infinity, because why? Because it is negative. F prime, and I could say it's because it's positive or negative? Positive, so greater than 0. Or positive, that's fine too, whatever. I'll do it the other one that way. And then I can say f is decreasing on what interval? -infinity to -1, because f prime is less than 0, or negative, because those are the same thing. So have we taken care of all of A? Yes. Okay. All right. So then B, relative max and min. Are there any relative maximums? No. So we need to state that, so it's not like we just left it out. We just say no relative max. And then F has relative min at what? Do I just put -1? X equals, good. X equals -1 because F prime, what? Good, changes from negative to positive. Changes from neg to pos. Okay. What questions do you have? We good? Okay. All right. And now, if we change from negative to positive or positive to negative, those give me two different things, right? For a point of inflection, it's just when it changes signs. That's why it changes concavity. So we don't have to be as specific. But sometimes I think it's better to be specific. That way you're not confused about when to be specific and when not to be specific. You know what I mean? So it doesn't hurt anything to say, instead of changes signs, which is what we're about to do, to say from positive to negative or negative to positive. The only time that gets a little icky is if you have to like list a bunch of them and they're all different or something, but it's still. So I think I'll still be specific here, and then until we kind of get the hang of it, and then we'll go from there. All right, so now I need to find the intervals of concavity and the inflection points. Well, the intervals of concavity, okay, concavity is where F prime is increasing or decreasing. I don't know that from the equation. That's why we need the second derivative, okay? So we're going to find the second derivative because we can. So F double prime of X equals, maybe I need more room for that. Fix that. Just move over a little bit. F double prime of X, because I have to write big. All right. So I'm taking the derivative here. What's the derivative of 3e to the x? 3e to the x. And then I have to take the derivative of this. What is the derivative of this? Did we already do it, basically? Yeah? So this is plus 3e to the x plus 3x e to the x. So, yes, I'd have to use product rule again, but because this part matches this exactly, the derivative of this is this whole thing, right? And if you don't see that or whatever, you can just find the derivative of it and you're fine, okay? Now, can I simplify that a little bit? Yes, so this equals 6e to the x plus 3x e to the x. And then I'm going to set that equal to 0, right? So the first thing I ask myself, so I don't do weird things, is, can I factor? Yes, I have a GCF. What is my GCF? 3e to the x. That leaves me with 2 plus x. Everybody good with that? Okay, so 3 to the x, I set equal to 0, and 2 plus x, I set equal to 0. Well, that is the exact same thing we did over there. We get nothing from that, right? And we get that x equals -2. All right, so then same kind of process here. We found the derivative, we found the zeros. We're going to do a sign chart. So sign chart, all I got on there is -2. This is F double prime. It's very good to label these for yourself and for whoever's grading this to know that that's what you were putting on there and those were your intentions, right? Okay, so I'm substituting back into this. Once again, this is going to be positive no matter what, so it's kind of irrelevant in my sign chart. If that was a -3, would it make a difference? Yes, absolutely, so I'm going to be careful there. All right, so I'm just substituting it in here. If I substitute in a -3, it's negative. If I substitute in as 0, it's positive, right? Now, because we have F double prime, that tells us stuff about F prime and about F. Who are we trying to talk about right now? F. Okay, we're trying to talk about F. We're not trying to talk about F prime. So here on the top, I'm going to put my F stuff, right? So if F double prime is negative, F is concave down. And F double prime is positive, it's concave up. So what's happening right here? Point of inflection. Okay. All right, so I realize that you may be kind of running out of room. You might need to draw arrows and kind of go up the sides or something. I apologize. Should have made sure that they were spaced better because I'm definitely running out of room, but I can keep extending mine. So just do the best you can. We'll get all these answers in there. All right, so what we were trying to find for C, intervals of concavity and the inflection points. Okay, so for C, I'm going to say F is, and I'll just start with the concave down because that's first. Concave down on an interval, right? It doesn't happen at an instant. So that's from negative infinity to negative 2. Because, who do we say that we know stuff about? F double prime is what? Negative, or less than 0. See, that time I wrote is, so I just, whatever. My brain doesn't even do the same thing every time. Then F is concave up on negative 2 to infinity, because F double prime is what? Positive. Are we done? No, because we were asked for a whole bunch of things. So we still have to do the points of inflection, right? So then I need to say that, where's our point of inflection? X equals negative 2. Okay, so then F has a point. Now, when we abbreviate it for ourselves, POI is okay. I've been told that on calculus it's fine. There's this big controversy in AP Pre-Cal whether or not we can abbreviate POI or it has to say point of inflection. Here's the thing. I don't want you to miss a point because you abbreviated too much, okay? So can you abbreviate point PT? Absolutely. We can say point of inflection, or like NFL, INFL. It's not infection, by the way, it's inflection. There's an L in there. F has a point of inflection at where? X equals negative 2 because, and who are we talking about? F double prime. And here's where we could just say changes signs. But again, just to be safe, it's easy just to say changes from negative to positive. I know that was a lot of writing with not enough room, sorry. Okay, so just to be clear, we put from negative to positive. We could have just put change of signs. That'd be okay. Here, if I just put change of signs, I'd be wrong. Because if it just changes signs, that doesn't tell me which kind of extreme it is, okay? What questions do you have? We good? So here's the good news. We don't have a ton of these to do to write over and over again. We're going to talk about the questions a little bit differently. All right. Any questions at all before we move on? We sure? Ask me a question. Yeah, if it was, because since it's going from negative to positive, it's going from concave down to concave up, but it's not asking me that. And whether I'm going from concave up to concave down or down to up, it's still a point of inflection. So that's why it doesn't matter. But again, instead of trying to remember when it matters, maybe just putting it every time is safer. You know, I mean, it's kind of in both camps. I don't know. Whatever works for you is fine for me, as long as you're getting it right. All right, anything else? Okay. Now, we're going to apply F double prime to linear approximation. So this says, write the equation of the line tangent to this function at x equals 1. Use your tangent line approximate of f of 0.9 and prove that your approximation is greater than the actual value. Is it asking me if it is greater than the actual value? No. It's saying prove it. So if I do it correctly, will this be greater than the actual value? Yes. Okay, so make sure when you're reading the questions you know that. So we saw that it says write the equation of the line tangent. So the first thing we do is point and slope. Okay. It tells me it's at x equals 1, so we put a 1 there. And so it's 1 f of 1 is what we want. And then my slope, f prime of 1. Okay. So let's find f of 1. What is f of 1? Well, that's pretty easy, right? I'm going to substitute it in here. It's going to be 1 minus 4. You agree with that? So this gives me 1, negative 3 is my ordered pair. In order to find f prime of negative 1, I need f prime. So let's do that. So f prime of x is 4x cubed minus 12x squared. You agree with that? So then f prime of 1 is just going to be 4 minus 12 is negative 8. So here are my two pieces here. Everybody good with that? Okay. So this is, we've been doing this a few times, so this isn't a brand new thing. So now my tangent line y equals negative 8 times x minus 1 minus 3. Okay, so we wrote the equation. That was the first sentence. Then it says use your tangent line approximate of f of 0.9, which means we probably need to find that. So f of 0.9 equals negative 8 times 0.9 minus 1 minus 3. Tell me why I would lose a point right there. I actually did this one on purpose, just so you know. Approximate. So I would lose a point here because of my equal sign. Okay? Y'all know I mess up all the time when unintentionally. I did do that one on purpose. It's approximately, right? That makes a difference because this says, you know, approximate of that. All right, well, in this case, even though this is a free response question, I can't just stop here because I have to know what it really is to be able to talk about whether it's greater than the actual value, that type of thing. Okay, you okay with that? So let's see here, f prime, so 0.9 minus 1 is what? Negative 0.1. So negative 8 times negative 0.1 minus 3. So what's negative 8 times negative 0.1? Negative, no, not negative, positive. So it's 0.8 minus 3. And now, at this point, I don't really care what the actual number is. The only thing that the second derivative helps that I need to know about it is the sign, positive or negative. So if I just know that, is this going to be a positive number or a negative number? Negative number, okay? I suggest you do that. So because if you subtract wrong, you might lose a point, right? And the actual number is irrelevant. We just care that it's negative at this point. We all good with that? Okay, so let's talk about how we can use this approximation to prove that it's greater than the actual value. Well, they kind of gave us a hint that it's applying f double prime to linear approximation. So even though there's not, well, let's see, we can do it right here. Let's write down your fun chart. So fun, because calculus is fun. Just jot it down. Try to do it without looking. I know it's to you, but I mean, the pattern's pretty easy, right? Yeah, up, down, and then up, down, up, down, up, down. All right, so I got an f value, because even though we used the derivative, this gives us the equation of the tangent line at x equals 1, right? And just with this graph, unless you just know what the function looks like, which you might on that one, but a lot of times you have no idea what they look like, right? And that's kind of the expectation. The second derivative tells me that whether it is positive or negative. I know that the graph itself is negative here, right? The approximation of that 0.9, because that's how we had to find it. And then I'm going to find the second derivative. So f double prime of x equals, right? And I'm sorry, I was talking about the negative like this was the second derivative, and it's not. My brain got ahead of me again. But here's my f prime. So f double prime is going to give me 12x squared minus 24x. You agree with that? Okay. So then I need f double prime of 1. Okay. F double prime of 1 is what? 12 minus 24. It is negative 12. Okay. So the function at 1, if f double prime is negative, right, then if f double prime is negative, f is what? Concave down. Okay, so I'm going to draw myself a little f function here. F, and it's basically just, it's concave down. Okay. Not only is it concave down, but my f prime number was negative, so it is concave down and it's decreasing, which means I know it's kind of on this side of it, all right? This is the equation of the line tangent at 1. Do I know exactly where 1 is? No, let's just say it's right there, okay? And I can't, there we go, right there at 1. So we found the approximate of f of 0.9, so 0.9 would be to the left of it. The approximation is greater, and it's greater because this is concave down. Anytime you have a concave down function, your approximate tangent line approximations are always going to be greater because it's always going to be above. If I have a concave up function here, then my tangent lines are always underneath. So that means that they would always be an underestimate. Does that make sense to you? So when it's asking us to do this, so we found this right here, and then we need to say, it says, and prove that your approximation is greater than the actual value. So all of our work, even though it's kind of all over the place, this would hopefully not be all over the place if you had more room. You kind of keep it a little bit more organized, but we're showing what we did here. So then we can say f of 0.9, oh, there's lots of words. Do y'all have some room to write? Maybe down the sides again? I think you could go down the side over here. Okay. The approximation, well, just approx, of f of 0.9 is it an overestimate or an underestimate? Does it matter, or can I get the words from the graph for the question? From the question. Okay, you can say it either way, but I'd go with the question. Is greater than the actual value, greater than the actual value, I can't spell, value, because f is concave down, because f double prime is negative. Don't tell your English teacher how many times I said because. It's not an English class, it's not an English test. So we can't just say, okay, so the reason that it's greater is because it is concave down. How do we know it's concave down? We know it's concave down because f double prime is negative. Okay, we good with that? What questions do you have? Y'all are amazing. We are going to pause here for today. I gave you a little white sheet of paper. Just hang on to that, and we will talk about that tomorrow and start back up right here.